Hi, my name is Sam White. I am a CS student at the University of Alabama and a React, Rails, and Rust developer. I had someone that reached out to me today via DM and was like, hey, I'm having a little bit of trouble understanding React state management solutions. There's a lot of them. There is useState, useReducer, useContext, Redux, MobX.
Yes, I'm not allowed to be friendly.
And a lot of other stuff, right? And as a beginner, it can be really hard to wrap your head around everything and know when you should use stuff and when you shouldn't. Today, this video is a quick little explainer of a lot of that stuff. Let me zoom in my size real quick on here. This video is meant to be a quick explainer of useState, useReducer, and useContext specifically, those three. How to use them, when to use them, and sort of how they work. So we're going to build a to-do list in 2 or 3 different ways. Actually, we're going to build a single to-do list and add on to it. So we're going to start off with useState, and then we're going to add on a few features, and then get into useReducer and the context API and why that might be important. Okay, so this is currently my dev environment setup. I have a Next.js server running right here that basically takes the components that's exported right here and spits it out over here. That's all it does. This index.js file just renders stuff out over here. Super simple. So whatever I develop in here will be spit out over here. The other important thing to note about Next.js is it automatically writes this at the top of all your files. So that you don't have to. If you're using something like Create React App, you have to write import React from React at the top of all of your JSX files. Okay, so let us get started. This also has a fast refresh server running on it, so when I change this over here, it renders out really quick over here. Okay, so building a to-do list app. Let's get started with the list part, creating a list in React that we can add on to dynamically. And the way I'm going to do that is I'm just going to start with the basics. I'm going to use useState. We're going to have a few pieces of state in here. Okay. So let's start by fleshing out a little bit of the HTML. I'm going to have a root div, and in this div, I'm going to have a form where we can add a to-do, and then I'm going to have a UL, an unordered list, where we can put our to-dos. And then each of these to-dos, I just want to be an li element, right? Inside our form, I want an input with type equal to text. That's going to be our to-do name. We're going to add a placeholder for that right there. And then we're going to have a button with type submit. Well, that's not right. Called add to do. And then we'll add on a few handlers and stuff to handle adding stuff. Okay, let's start by wiring up this form. The way we're going to do that is we're going to have a state variable for this input text, right? So we will create a create a piece of state with useState with the initial value of just an empty string. I'm going to call this text for right now, and then the function to set it we'll just call setText. And then we'll wire it up right here on our input. The way we do that is we set the value property of the input to be our little text variable, and then we write a, and let me save this. Well, no, that didn't work. I have Prettier running, and it should be reformatting this to look prettier, but it's not. So we'll set the value property of our input to our text variable, and then for the onChange property, we'll pass in a function that calls setText and sets the value to e.target.value. Pretty basic stuff, right? Okay, so Now we can type in this input, right? That's not a surprise. If we actually render out this text value, though, we can see that it's syncing up to what we type in here. Okay. Next, let's create our actual to-do list. And the way we're going to do this is we're going to have our to-do list be an array. It's going to use another useState value with initial array value. We'll call this to-dos, and the function is setIt will be called setToDos. Okay. First, let's start by rendering out each of our to-dos, even though we don't have any right now. Or no, let's handle to-do creation. So the way to do to-do creation is on this form, we're going to add an onSubmit property. Because this button is a type submit, whenever we click it or whenever we press enter while in this input, it's going to call the onSubmit handler right here. Okay. So the first thing you want to do in all your onSubmit handlers is call e.preventDefault. That way it doesn't have the really bad behavior that when you click add to do, it reloads the page. Okay, so e.preventDefault prevents that from happening, so that now when we do this, it just calls that handler and doesn't reload the page. Okay, next we are going to add the actual to-do, and the way we do this is we call setToDos. We pass it a function where the only argument is the previous state, and then we just return in that function our new state derived from the previous state. Okay, so in this case, we're going to return a new array that has all of the old array's contents like this. It's really, really important that you use this syntax. I'll show why in just a sec, I think. And then at the end right here, we'll just add our text variable. This is going to be an array of strings. Okay, last we will set our text variable, our text state to be our empty string again, and this will reset the input. So now when we reload this real quick, you can see that this is resetting every time. Okay. Last, let's render out each of these, each of the to-dos, and we'll do this using todos.map. We'll pass in a function that has a to-do variable as the argument, and then right here, we'll just return an li, and then render out the to-do. Okay, so now this, if we add a few to-dos over here, should add to-dos. Okay, awesome. So now we have a list that automatically, that will let us add stuff to it. Cool. All right, real quick on why I use this syntax right here, this little array spread syntax and creating a new array. When you're using useState or useReducer, you need to return a completely new array every single time. That's the way that React checks to make sure that it needs to re-render. So if we do something like this in here, if we call prev.push text, right? And that's all we do. If we just mutate this variable right here, you're gonna notice that React sort of blows up at us, right? And that's because right here we're not returning anything. If we return prev right here, I mean, it works, but this is not the recommended React way. I didn't actually know that would work. So the recommended React way is to think in terms of immutability, to avoid doing stuff like using push and pop and unshift, and instead to create entirely new arrays like this, where you have the old array and then you just like add text at the end, or you put it at the front, whatever you want to do, but where you're creating a new array and avoiding immutability as much as possible. Okay, so now we have our to-do list app. I guess the next step is I want to be able to remove to-dos. I want to be able to delete a to-do. And so our way of doing that is going to be adding a delete button onto this li. So let's add a button right here that just says delete. There we go. This doesn't do anything. But what we can do is we can add an on-click handler to this button right here, where on click, we're going to do some set to-dos magic. Okay, we're gonna need to do something. We're gonna need to modify our to-dos somehow, and in order to do that, we're going to need an index variable in here. The second argument to any function passed into map is the index. The first argument is the item. So we're going to set to-dos and add or pass in one of these little functions in here with prev. And we want to remove whatever is at our index, right? That's the only element we want to remove. The immutable way of doing this is to use the array.filter method. And how that works is you pass it a function that has this same sort of shape as the map function, where the first argument is the first argument is an individual item in the array, the second item is an index, and then you just return true or false from that function. If you return true, that element stays in the new array. If it returns false, that element gets removed. So we're going to pass in a function, if I can get it to, with to do index or other index, I guess. And then we want to make sure that our other index is not equal to our index. And then that should let us remove to-dos. So testing this out. Well, what did we do? That's curious. I don't know what I did there. Oh, this needs to be a function right here. Every little thing you pass into onClick right here needs to be a function. You do not want to just evaluate set to-dos here. What this was doing is whenever this was rendering out, if you don't have this little function right here, it's calling set to-dos, right? And just removing the element whenever you add it. That's not what we wanted. And that's why, kids, you use TypeScript. Okay, so adding a few elements, we can now delete them. Okay, that is awesome. Okay, so, it also looks like we can add an empty to do. Let's add a quick if in here, if our text.length not equal to 0. So we can't add an empty to do, because that would not be good. Okay. So now we can remove elements. We can't add empty ones, which is awesome, but we can remove elements safely. Okay. So let's make things a little bit more complicated. Instead of just having, remember this right here is an array of strings. We need to add on some additional state to each of these to-dos, right? Because in a to-do list, you want to be able to mark a to-do as completed, and you want to be able to you want the to-do to have a name, and you want it to have a completed status, right? So instead of doing this, we're going to make this an array of objects that have sort of the shape like this. Imagine this as an object where the name is a string and then completed is a Boolean. Okay, and if the Boolean's true, it's completed. If not, it's false. Okay, so let's do this. Our way of doing this is first, we're going to need to edit where we create to-dos right here. So instead of just passing in a string, we're going to need to pass in an object where our name is our text and completed is false, right? So now in the only place where we're adding on to our to-do array, we're making it an object, not a string, okay? This is important. Okay, next down here, where we are rendering out our to-dos, we're going to make this, we're not going to render out our to-do because that's going to be an object, as you see, right? And React will throw an error saying objects are not valid as React child, blah, 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 whatever. So we need to, instead of rendering the to-do right here, we need to render the to-do.name property. Okay. So now this is working as it should. And then really last, what we need to do is render out a checkbox, which I think, oh God, I don't know what an HTML checkbox is. Input type equals checkbox. Value equals todo.checked. Okay. That's not working correctly. Oh, not todo.checked. Value equals todo.completed. Sorry. I was about to say, well, it's still letting me mutate that. I don't think I'm doing this right. See, when we pass in a value to an input field like this, the result should be that it becomes immutable. Like right here, if I comment out this on change right here, it becomes immutable and I can't type in anything because that text value is not changing. So I need to look at React checkbox stuff. Oh, React has a nice, the checked value, that's it. So this is checked, whoa, sorry. This is checked equals this. There we go, and now this should become immutable. Okay, cool. Last, let's add an on change helper to this, and then I guess we'll just say, oh God, we're gonna need to, this is where it starts getting a little bit wonky. Sorry, my watch is yelling at me to stand up. I actually want to kind of close my range today. Okay. So, adjust my laptop real quick. Okay. So, we need to, now that we're showing our checked status in our little to-do list right here. This needs to like actually check the items. So what we're going to do is in our on change helper right here, we really want to just toggle the item on this to-do, right? However, that, as you're going to see, is just it's gonna stink. It doesn't feel right. Actually, I can't remember what the output for e.target.value is. What happens right here? Okay, false. What if we say current target? Okay, so we're just gonna toggle our to-do completed status in here. Oh, I forgot the other thing. Whenever you're using a map, you have to add on a key value to the thing you're returning. That's why React is throwing a value or an error right here. So if we had a key thing on here, it's no longer going to scream at us about that. And that's an important optimization that enables React to render everything out really, really fast. Okay, so shoot, what do we want to put in this on change thing? Well, I guess what we want to do is we want to set our to-dos first, and we need to return something new. So we're not removing an element. So the immutable method we want to use is the map method, which lets us go over each item in the array and just change it however we want. And then it returns a whole new array with all the elements, but in the way we changed them. Okay, so this has the same exact syntax as right here. I'm gonna create a function that has a t argument and an I argument. We want to return t by default right here. This is getting ugly, don't worry, we'll fix it. if our I variable is equal to our index variable, so if the element we're going over in our to-do array is the same element we're in right here, then what we're going to do is we're going to return ... t, creating an entirely new object, copying the to-do stuff in there, and then on here we're going to set completed to not t.completed. Okay, this is a mess, right? But you'll notice that it works now. We have a completed status. We can do, to prove this, we can do something like add an h1 in here and say completed to-dos, and this is to-dos. Oh shoot, I really should not do this. To-dos.filter t.completed.reduce. Oh no, .length, sorry. So like this will show our number of completed to-dos, right? Creating a whole new array with all that in it. Okay, so we actually have the stuff doing this. Okay, so I'll leave that in there real quick. But you'll notice that this is really, really ugly. It's not very pretty. I don't like how this looks, right? This doesn't, you know, as we add on more features, like if we added on like actual lists, this is just going to get more and more and more disgusting. So, well, let me show you how this can get more and more disgusting. So one of the things you do when your component starts getting big like this and it's doing multiple things like adding a to-do, but also managing all the to-dos, is you split it up into smaller components. So one thing we might do here is take all this mess right here and just stick it in another component called to-do component or something like that. So if we have a const to-do component, and some props, and then let's say one of the props is a to-do. One of the props is also going to be our little set to-dos method that we can call. And let's copy all the junk that's in here, move it up here, and just return it like that. Surrounding it with parentheses so I don't have to think about prettier messing with that. What did I do? Oh, it's screaming at me about this. To-do component. To-do equals to-do. We need an index variable. We need a set to-dos equals set to-dos. Like that. Ew. And then everywhere in here, we really just need to do to-dos, index, set to-dos, and then we should have another component, and then this should work. Nope. To-do is, oh, sorry. My display just froze for a second. Okay, I'll explain what I'm doing in just a sec. It's also not important that you follow along with it. With all this, it's just mostly important that you understand what I'm doing and why I'm doing it. Okay, so what I did right here is I took all the code that was in this like todos.map mess, right? And I stuck it in here and made it into a component, right? Then all of the little variables that it depends on that come from the scope of this like todos.map function, and then this stuff right here, I passed those in as props, right? So you'll notice we have to-do equals to-do, index equals index, and set to-dos equals set to-dos. So we're passing that set to-dos function down so we can access it inside here, right? Then right here, those props are passed in as the first argument to any functional component. So right here, what I did is I just destructured that first argument, and I just wrote to-do, index, and set to-dos because that's what's on our props. And then that just allowed me to have the same component right here without all the other mess. Okay, cool. What might be a better way to do this now is, I'm trying to think of an example that would let me introduce the context API. Because really what the context API is about is it's about, oh, we forgot to add our key thing onto here. So key equals index. Whoops. Sorry. Okay, this should still work. I'm trying to think of something complex I could add to each of these to make this trickier. What if we allowed recursive to-dos? That'd be fun, wouldn't it? That'd be very fun. Let's do recursive to-dos. So let's say we want to render out this this thing right here on each and every single one of these to-do components. That's going to be fun. And this is the perfect use case. So this is going to require us creating an add to-do component. Let's see, what does this depend on? It just depends on set to-dos, and then it has its own internal state, this set text right here. Okay, so it just depends on set to-dos. So we're gonna respect that as a thing. And then we'll return our little form mess right here, paste it in here. I'm not sure actually. Oh, this is going to be complex. This is going to require a recursive reducer. It is 4 p.m. now. So this depends on set to-dos, and then this set text right here just needs to get pasted up in here. Okay. And then last, we need to set our add to-do function in here. Or add to-do component right here, set to-dos. Set to-dos. Okay, so basically I just did the same process right here. I took all this form mess right here. I moved the state that the component depends on, like that's that same set text variable, right? And I moved it up in here. And after that, I basically just passed down the same set to-dos thing. Okay. So if we want this little like add to-do component to be rendered out with each of these, we can actually, we can do that right now. So like down here, we can just render out add to-do like this, and pass down set to-dos like that. And you'll notice this works, but also it doesn't produce the behavior we want, right? Let's also add a BR thing in here, because that's hard to look at. Let's add a few. Okay, let's add just 2. Yep, that looks right. Okay. Let's add one at the top as well, because I don't like how this looks. This is not meant to look pretty. Okay, I think that works. Okay, so you'll notice that like this works a little bit, right? But it's not really doing what we want. It's just appending to this existing list, which is not really not what we want. So the way we're going to do a recursive solution to this, and this is going to be a real mess. This is going to be so bad. But the way we're going to do this is we are going to have a single array, right? Keep our little to-dos array, and then let me do this right here. This object that we're going to have in here, this to-dos object, instead of it just being having a name, it's a string, a completed value that's a Boolean, and that being it, it's going to have an ID, which is a number, and then we're going to have a children array, which is an array of numbers, right? And how this is going to work is up here, we will just go over, in our to-do component right here, we'll just go over each of our children, render them out, and then render them out recursively using this to-do component thing. And then when we need to add a to-do right here, we can just append the to-do to the array, right? This is a little hard to think about. We can append the to-do to the array, take that ID, and then just stick it on this to-do's IDs. This will make sense, I promise. Okay, it's flattening it out, and it's going to be real messy code, but we'll clean it up in a minute. Okay, so let's get started by fixing this up. So the way we're going to do this is we need to add an ID property, and that's going to be prev.length. So if our array is 0, yes. So this ID is basically just the index. I'm just adding it here so it makes debugging easier. Prev.length, if our to-dos array is 0, the first index is going to be 0 when we add it, right? If our length is 1, then after we add this, the length is going to be 2, and this thing's index is going to be 1. Okay, so we're going to do that, and then we're going to add an empty children array. Okay, next what we're going to do is we are going to, we're going to need a root array of children. I think like this. This is not the best way to do it, because in order to render this out, we have to have some sort of starting point, like a starting index. In our to-do component, we are going to do this. This is where it's going to get very, very messy. First, in our to-do component, we need a list of all the to-dos. So we're going to pass down each and every to-do, right? Context will improve this a lot in just a minute. You'll see why. Okay, so we have every to-do in here, right? Then what we're going to do is, instead of passing in a to-do right here, we just need the index, really, right? Because we can say right here, const to-do equals to-do's index. Super simple, right? So we can remove this right here. I'm going to change this index to, well, no, we're going to keep that. And then last, this is going to be the key. We're going to take our to-do.children. We're going to map them. I'm going to say ID right here. And then we're going to call, well, we're going to return right here to-do component and start passing all these variables down. Key equals index. Oh, this is, well, no, this is going to work. Key equals index. What else are we expecting in here? Index equals index. Set to-dos equals set to-dos. And to-dos equals to-dos. Okay, so passing a lot of variables down. Okay, so this is not going to do anything currently. We just need to fix this add to-dos method to have some context to it, right? A little index to add to. So oh, this is gonna be this is not gonna be good. How do I want to do this? This is where it gets tricky, because we need some sort of like children array. So I suppose we could just have a single root to do right here, just to simplify this a little bit. So have a name be initial completed, be false. ID is 0, and then children is this right here, and this would solve our problem. And then right here, we just render to-do component, key equals 0. Well, we don't need a key. Index equals 0, to-dos equals to-dos, and then set to-dos equals set to-dos right there. Like that. So that would fix this problem because we wouldn't have to have this children array. Okay, we're gonna do that. That's a cheap trick. It works though. Okay, so now add to-dos needs an index field like this. This is just going to be, well, yeah, we'll call that an index field. And this is just going to be the ID of the to-do to add to. So our index right here is going to be 0. And our index up here is just going to be index. Okay. And then in here, all we need to do is, instead of this simple function, we need to add this new to-do to the end. We also need to do a map after this to clean up that last element, right? So actually, probably the most efficient way to do this would be to create this new array, right? And then let me fix this. Create this new array. This new to-dos. Once we create the array, we can modify it directly. This way, we're not iterating over all the to-dos a second time. So new to-dos index dot. I don't know what I want here. Dot. Oh wait, no, we can't do this. We're gonna have to map over this. Rip. Sorry, because we're modifying an object and JavaScript objects are confusing. Okay, this is gonna freak out. There. Okay. So right here we need to do a map follow-up call. I'm just gonna use a ternary operator. Children. This is really ugly. Oh my god. Okay, and then this should work. I do believe this will work. Nope. For some reason, oh wait, no. T.children, and then I index. No, prev.length. That should work. Okay, so now we should have our recursive editor. I think we just did an infinite loop. Shit. Fuck my life. Ha ha ha. Wait, what did I just do? Okay, so like if I do a to-do right here and do ASDF, add to-do. So the whole browser freezes up. What did I do? Okay, we create a new array, we add a new object to the end of it. Name is, oh wait, see, name is text is right. Completed is false. Map t of I dot t children dot t children. What did I do? I don't know what's going on here. Okay, let's just try pushing this to the array real quick. My laptop is heating up and I don't know what it did to anger it. Okay, well, this Chrome tab, oh wow, what is it doing? So adding to-dos confirm doesn't work. Okay, this works. That's expected behavior. So we have this new array. Maybe it might be better if I actually wrote this out as a function. And this might be one of the bugs that we fix in just a minute. So it's return new to-dos dot map. Ti. Yes. If I equals index, then we'll return our children is going to be children, t.children, sorry. And then we're going to pass in useTodos.length. Well, no, prev.length for that. Okay. Else return t. Okay. So, as far as I know, this should work. I don't know why it's not. I feel like if I had TypeScript in here. Man! New to-dos.map. It's a type error. I feel like it's a type error. Okay, let's add a debugger statement in here because I am tired of this. Let's see how long this is running real quick. Okay, so we start by adding in a thing. We're not even hitting the debugger statement. Ooh, that's an issue. Okay, so something about that map statement is causing this to fuck up. Okay. Little did you know, this is just gonna be me doing 6 hours of bug fixes. Okay. I've done my standing for the day. Watch, stop screaming at me. It's 4. I have 8 hours more of standing hours to do. Okay. What about this map is it not liking? Because this should work. Okay. I feel like it's actually in our rendering. It's something I did in the rendering that's causing it to be. And part of this is I am extremely used to, okay, we have our debugger. What is our stuff right here? New to-dos equals this right here. I equals our index. What's our index? I feel like that might be it. What's our index is 0. This new to-dos.map function is never running. Do we have a t variable that's being used? No. And then for some reason, when this happens, nope, it goes to this debugger. Okay, t name equals initial completed false. Children is an array 0. So t t children t.children prev.length. That should work. Prev.length. What is our length of prev? Else return t. I seriously don't understand what's going on with this. What is it? It's in our rendering, I knew it. It's something about this. That would be it. That would be it. I'm dumb. I'm so dumb. ID. That's it. It's infinitely rendering the same component. That's why it got stuck. Ugh, I hate recursive code. Okay, that's not something TypeScript would have caught. Okay, now, yes, there we go. Oh, we should stick this inside a second UL also. There we go. We have our brand new little recursive to-do array thing. Now we can actually, oh, ew, that is so ugly. This is actually really, really beautiful. I mean, it's not beautiful by any means, but this is really cool that you can, I love recursive solutions like this. We can just render something out infinitely deep like this. Okay, oh, and this still works because it's in a flat array. Okay, this code is fucking ugly. It is so ugly, and my display is not where I need it to be. And our job now is to clean it up. And the way we're gonna do that is we're gonna use useReducer and useContext, okay? So that we're not passing down this to-dos array, so we're not passing down this set to-dos array, so that these components are not responsible for setting the state, right? We're gonna have a single definition of how we set the state. So we have two major transactions here. We have one where we set a component to a to-do to true or false, right? And then we have one where we add a new to-do. So in a we're only going to have two different state things that we need to do. Okay, I have to look up the documentation for useReducer and useContext because I don't remember how to use them. Once you know how to use useReducer, though, it's basically the same thing as Redux. So useReducer, we have a reducer, initial arg, and a init, an alternative to useState, state, action, new state. Okay. So let's write our reducer up here. It's going to, a reducer, for those of you that do not know, is a different way to reason about your state. Instead of having how you define your state littered throughout your code in multiple different places, a reducer is a single function that defines your state and all changes that can be made to it, right? You cannot modify anything unless if you do so in the reducer. And the way that works is it is a function that accepts in the current state and an action. And an action is, you can sort of think about it like a transaction, like some sort of change you're asking the reducer to make to the state. So the reducer looks at that action and says, okay, you need to do this. I know how to do this, or I don't know how to do this. And then it returns a brand new state. It returns a new state, right? It doesn't mutate the old one. It returns a brand new state. That is very, very important. So that's how it works. And it basically lets you reason about your state a lot better. useReducer is a way of passing in, look at this real quick. useReducer accepts in a reducer and then some initial state. In our case, that would just be an array with this right here, right? So it's very, very similar to useState. Then it returns a single variable with all of your state, and then returns dispatch, which is a function that lets you send actions to this reducer. So it's a little bit different than this like set to-dos thing, but it's a lot easier to reason about. So we're going to define a reducer that lets us do all of our stuff. Okay. This might not make sense. It'll make sense after you implement something with it. Okay. So a reducer accepts in some state and some action, right? And we have two actions. Let me do a little bit of brainstorming right here. An action is an object with, it has a type. Actually, an action can be anything you want it to be, really. So it is a, usually though, it's an action, it's an object with a string, a type string, like that. It is a key type, and then it has a string value on it, and then it has some other properties on here that are specific to each individual action. So we have two actions here. We have one where we are creating a to-do, and then we have one where we are toggling a to-do. So for creating a to-do, I'm just gonna say our action is gonna look like this, called create to-do. Our little, this is called the payload. And our payload right here is just going to be the name, which is gonna be a string. Okay, toggling a to-do, this is super simple. It's going to be toggle to-do We need the ID, or parent ID, right? That little index thing. Toddling a to-do is super simple. We just need the ID of the thing. Okay, of the to-do. Okay, so now with this in mind, we can write a reducer. And the best way to do this is to write a switch statement around our action. Our action.type, right? And what we can do is we can say, okay, let's do one branch for create to do, break right here. Let's do one branch for toggle to do, this break right here, and then our default is we just return state right here. Okay. So when we create a to-do, the state we return is super simple. It is our previous state. Remember, our state right here is an array. This is our to-do list, right? So we return our previous state. We add the new to-do to the end, and our to-do has this structure. So name, action.name. It has a completed number, or completed ID, completed Boolean. It has an ID, which is our state.length, and then it has our children, which is a array. Then after this, we map this entire thing just to modify that one variable. This gets super verbose. We need to return this too. So we map, do a dot map with ti, if I equals payload.parent, action.parent ID. Then we do this whole mess right here. Shit. State.length. And else we return t. Okay, so that's how we add a to-do. Toddling a to-do, super simple. We already wrote it. Ti, and we just say if, I'm going to use another ternary symbol. I equals action.id. Then we're going to create a new object. Completed is going to be t, or it's going to be the opposite of t.completed. Otherwise, we're going to return t. Okay. Oh, apparently we don't need these break statements. Awesome. Okay, so we have a reducer now. Now we can pass this into a useReducer call. And then we're going to use useContext in a minute to simplify things even further. Okay, so notice how we're going to be able to eliminate a lot of our state management code, right? This looks complex, but like we already wrote it. It's literally this set to-dos call right here and this set to-dos call right here, right? Those kind of look ugly, they're confusing, and it's really not, it creates coupling between the implementation of our logic and how we present stuff, which is not really good when you're developing a React app. So what we're going to do now is we're going to swap out this to-do stuff for a useReducer call. So we're going to say, I'm going to call this state and dispatch, but this equals useReducer, to-dos reducer. Let me rename that real quick. Okay. And then our initial state is an array with this mess inside it. Okay. So now, wherever we have this to-dos function, we can just, where we have like set to-dos or our state function, we can just swap it out with dispatch, right? So to-dos now can become state, and then set to-dos can become dispatch. And then I think we should be able to rename this to dispatch, that, and then this to-dos to state, and then this set to-dos to dispatch. Okay, and then going up. Oh, well, it didn't change any of that. Shoot. Well, let's rename it right here. Set to-dos is dispatch now. This to-dos thing right here is our state. Okay. Super simple. Okay, so now we can get rid of all this ugly logic right there. Look at how much code we just got rid of. Ah, that feels so nice. And then in this dispatch right here, we can just send an action. So right here, we can send an action called toggle to do, and where our ID is our index, right? And then that'll just get passed into our to-dos reducer. And then down here in add to do, let's change this to dispatch, remove set to-dos right there. And then this big old ugly function call gets simplified down to this. Watch, type is, what was our action type up here? Create to do. Our name is text right here, the value of that input. And then our parent ID is our index, just our number. And then if we did this right, which I think we did, oh wait, we need to swap out this to-dos with state.filter. If we did this right, this should work. And it has greatly simplified our code and made it a little bit more beautiful. Okay, reloading this real quick, add a to-do, and it works. Look at that. So now if we say want to add on a feature for, oh, we need to be able to remove a to-do too, don't we? We have code in here that does that. So if we need to be able to add on code to remove a to-do, that's just a simple type remove to-do ID number action, and then we just add on a case right here for that. Shoot, I'm sorry. And then we just do state.filter ti, where I not equal to action.id. And then down here in our code, wherever we have that remove, that delete button right here, instead of having the logic right here, we just say, we just pass an action like this. Is it delete to do or remove to do? It's remove to do. And our ID is an index. So now, well, no. Oh, I forgot. We need to, oh shit. Ha ha ha. Fuck. How would I do this? How do I do this? So right here, the problem is we are removing the to do, but we're not removing the, right here, we're not removing the ID from its parent ID thing, you know? So really what we need is a, on our to-dos object, we need a parent ID object, I guess. Yeah, so like right here, parent ID 0. And then when we create a to-do right here, our parent ID is our number. No, not number. Action.parent ID. We can actually leave this to-do floating around in the list. Like we don't actually have to do the work to remove it. We just have to remove it from the parent ID now. The parent ID is list of children, and this makes it really, really easy to do a lot of cool other stuff. So like let's leave that in there, and then remove a to-do is simply going through here. We're going to actually map over this, and well, first we need to get the parent ID. Right, so this is const parent ID equals state action.id.parent ID, and then we need to remove that. The way we do that, or remove, yeah, Okay, sorry. Then we need to do a map over this ti. This is going to be so hard to follow, and I'm so sorry. If I equals parent ID, then we have some other code we need to do, else return t. We return ... t. Children is t.children.filter underscore j j not equal to action.id. Okay, and then this should work. Well, no. What's going on here? This is the other thing, right? This is some really, well, did not read property completed if undefined. This is some really, this is another advantage of this, right? We have one definition of how our state changes. If we had written this code down here, it would have been a mess, but it's not. So we're passing an ID, which is an index. So when we're adding a to-do right here, and we delete this to-do, oh, this is doing the, this needs to be j underscore. That's the issue. We're comparing against the index, not against the other stuff. Of course, it's never going to remove something. Okay, advance forward. There we go. That produces the desired result. So now we're able to just remove stuff like that. And it removes all the children too, which is really, really awesome. If we add something down here, if we have a long chain right here, we delete one at the top, that just gets removed. Okay, so yeah, there we go. Super, super, super simple. Not simple, but super, this simplifies things a lot. Okay, last thing I want to leave you with is simplifying this right here, removing this state equals state and dispatch equals dispatch thing right there, right? Because if we had multiple components, multiple other components in this to-do, that were called in this to-do component, and they all needed this global state, that would be very, very ugly. So what we're going to do is we're going to use the context API. Or import useContext. So the way this works is I forget how this works. Okay, we're not going to pass in a default value. The way this works is it lets us reference a single sort of global value thing right here in all of our components right here. And then we have a typo, rip. Instead of having to like have these annoying prop pass downs, we can do something like this, right? So I'm going to say to use context.provider. This is where we set the value that can be accessed in any of this component's children, right? We're going to set our value equal to an object where our state and our dispatch things are passed in. Then we can, up in here, instead of having dispatch and index be passed in right here, we can just replace these with useContext calls. So dispatch is equal to useContext, and this is to-do's context. And we need to destructure like that, and then we can remove this right here. And our other dispatch in here, well, this needs to go up here. Equals useContext to do's context. Okay, Something like that. Identifier dispatch. Oh, we gotta remove it from right here. Okay, there we go. Now this should work, I hope. Identifier dispatch has already been declared. Where? Oh, no, there we go. There we go. So now it's, what's happening here is that React sort of behind the scenes with context is like sort of putting this, this state and dispatch object in a little variable right here that we can just access anywhere in this component's subtree, right? That's really important to understand. Anywhere where the component is a child of this like provider, right? And so now instead of having to do these really ugly prop pass downs, right? Now we can just eliminate those like this and like this and like this. And now we just have components that just rely on this context. So that greatly simplifies our code. It makes it look a lot better. And then even though there's a lot here, it's a lot more manageable, right? If you want to swap out the state, you only have one place you need to do that. Or if you want to rename it, right, you don't have to go through and rename a bunch of props. It just sort of works. So context is just a way of simplifying the number of props that you have to pass down. Okay, so we now have a recursive to-do list. I'm actually pretty proud of this. I'm surprised that I was able to make this really, really quickly. But yeah, it lets you make to-dos really, really easily and do deletions very, very simply. The other thing is we've gotta fix this right here. It's gonna require a recursive call to fix this completed thing. But anyway, so yeah, that's the video. I'm gonna upload this to my YouTube channel. Let me know if you have any questions. There are parts where I went pretty fast. But basically all you need to know is a reducer is a way of like centralizing all of how you change state, all of how you modify a state. That the way you change state with reducers is by passing an action object that the reducer works with, right? And that context is a way of simplifying prop pass downs. So we have nice, beautiful pass downs with only a single prop right here. Okay. That was a lot. Rewatch it a time or two. If you have any questions, which you probably will because I probably forgot to cover something or I didn't explain something right or yada, 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 please, please, please reach out to me, tweet at me, whatever you need to do, and I promise I'll get back to you. Okay, thank you so much for watching, and wow, that took an hour. Okay, all right, goodbye.